Okay, so today is probably one of the more anticlimactic days in class because we don't get to do anything 3D and fun and all the rest of it, but we have to start somewhere. And I want to give you guys a really good fundamental overview of how Rhino works, what the coordinate system means, and all that sort of thing. So today we're only going to draw in 2 dimensions. Next Monday we'll start in 3 dimensions again. So this is really going back to the very basics, but I want to kind of talk through how the system works so that you're more familiar. If you've worked in AutoCAD before, you understand that there's a coordinate system in AutoCAD too. All of you took, or a large percentage of you took 135 with me. We talked about AutoCAD. We talked about this exact thing in AutoCAD. The drawing on the back should look very, very familiar to you guys, but this time we're doing it in Rhino. The point is that I want to emphasize the coordinate system, the underlying fundamentals behind Rhino. So I'm going to go ahead and open up Rhino. And we're going to start completely from scratch today. So there isn't a file for you to download or anything else. We're just going to start from scratch. When we first open up Rhino, we get this little splash screen that opens up. And there are a bunch of templates that are loaded up for us that we can pick from. We always want to pick the large object inches template. For the stuff that we're going to be doing, we want a large scope, a large drawing area, and we want our default units to be in inches. So we pick large objects inches, we let Rhino finish loading up, and the hope is that it's reasonably configured for you. As I said before, we're going to, let me go ahead and say OK here, we're going to assign seats. Probably starting next Monday is when you'll get in your seat and then you'll stick with it. I won't specify you have to sit in this seat, you have to sit in that seat, but I'll pass around a sheet that you'll sign up for. This is where my seat's going to be. It'll have the computer number on it, and you'll sit there. Then either on Monday or on Wednesday next week, we will unlock the computers. You'll log in, and it'll save all your stuff. And at that point, I'll emphasize a lot about how we set up the workspace for you, and then it will always be the same when you log in, which is the idea. So for right now, you may have to do a little bit of customization, but mine looks the same as it did last time. This is kind of the target for what we want to work in. So as I said last class, there's 4 different views that come up by default. We have the top view, which is the straight down view. We have the perspective view, which is obviously the 3D view. We have the front and the right side views, very much the orthographic projection that we're used to. Today, we're only going to work in the top view, so we're not going to do anything in the Z direction, in the 3rd dimension. Okay, everything's going to be flat. So we're going to go ahead and double-click where it says top, and this will make us just have the top view. Okay, this looks shockingly similar to what AutoCAD looks like in the top view. AutoCAD has the top view. This has the top view. And again, everything that we're drawing is going to be on a flat plane at z equals 0. So in the 3rd dimension, it's going to be flat on the ground, so to speak. So with Rhino and with AutoCAD, these computer programs are driven by fundamental math. Okay? And this is like back in the world of algebra and stuff, maybe a little geometry as part of it. But basically what we have, do you guys remember back to algebra when you had to graph a function and you had like an XY grid? Do you kind of remember this a little bit? And you had an equation and you had to figure out where it went and that sort of thing. Rhino works very much the same way, where we have a coordinate system like this, and we have an x-axis and we have a y-axis. We have a z-axis that comes out toward us too. But what we're working in today is just x and y. So we can, for example, specify some point that has an x coordinate and a y coordinate. And we would write it as x comma y. Okay, does this vaguely, you guys remember this a little bit? Maybe? Maybe not. Okay. We're going to be using this to our advantage today. So the way Rhino establishes this, the x direction goes positive from where these red and green lines meet. So that's x going positive. This is y going positive along the green line. Okay? So point 0, 0, which is called the origin, is right where those 2 lines meet. Okay? So today we're going to start drawing right at that origin, right at 0. And that frequently when we work on our drawings, 0, 0 is going to be where we start our drawings. Okay? So when I go to type, and I'm going to work with just the basic polyline tool here to start, which is the second little tool down. It looks like a little angle. When I click on that and start my polyline, okay, I'm going to type in 0, 0 to start. If I just said, oh, you know what, I'm really good, I'm just going to click my point right at 0, 0, life will be good. Right? The problem here is if I zoom in on that point, see as I zoom in, it's not at point 0, 0. Okay? Even if I say, okay, well now I'm zoomed in, and I'll click right on point 0, 0. All right, I got it. As I zoom in a little bit further, guess what? It's not on point 0, 0. So Rhino is all about accuracy, and we want to make sure that we have these points accurate. So instead, let me zoom, extents. I press Z and then, oh, excuse me, Z, enter, and then let me do, actually I can't do it yet because I don't have an object. Let me just scroll wheel back out. There we go. OK, so let me start again with that polyline. And this time, instead of trying to click at the origin, I'm going to type 0, 0. Okay, and we can see that come right here. And so that coordinate 0, 0 means start at the origin. So I'll hit enter, and it shows up at the origin. Now, if I were to zoom in, the further and further I zoom in, you see that it's always right at that 0, 0, which is exactly what we want. Okay, so let me zoom back out here for a bit. There we go. Now, the next point that I want is I want a line that's 24 feet long right along the y-axis here. Okay? So in order to do that, I'm going to go ahead and type in what's called an absolute coordinate. Right? So I would know in this world, right, this point right here is 0, 0, and a point that's up here, right, by 24 feet would be 0, because we start with the x coordinate, that's 0, and this would be 24 feet. Okay, so if I were to type in this absolute coordinate, I would type 0, 24 apostrophe. Okay, the apostrophe represents feet, the quotation mark represents inches. So 0, 24 feet. And I'll go ahead and hit enter. Okay, so we see that I have a straight line that goes straight up here that is 24 feet long and ends at that point. So let's say that I wanted to go over 12 feet. Okay? If I was again doing absolute coordinates, and I wanted to get this point right here, and it was 24 feet up and 12 feet over, okay, this coordinate would be 12 feet, 24 feet. Does that make sense? Okay? So I can go ahead and type in that value. 12 feet, 24 feet. Sorry, in the math world, you tend to put parentheses around the points, but in Rhino world, you don't have to put parentheses. So I should be clear when I write it there. OK, so 12 apostrophe, 24 apostrophe. And I'll go ahead and hit enter. And that then creates a straight line that goes over 12 feet from where I was. Okay? So thus far, we've done everything as an absolute coordinate, which means we know where point 0, 0 is, and every point that we pick is relative to 0, 0. Okay? There comes a point in time when you're drawing where you don't really know where a particular line needs to go based on the origin, or based on 0, 0. Okay? So for example, the next line that I'm going to draw is down 6 feet from here. And so I could do a little math, and I could say, OK, well, that would be 12, 18 feet, right, if I was doing the math in my head. But it's starting to get a little complicated. So instead, I'm going to use something called a relative coordinate. And what a relative coordinate does is it pegs your origin for the next command based on the last point you clicked. So now I'm only doing relative to the last point. So the last point I clicked was right here. If I want to go down by 6 feet, I can type the @ sign, which is for relative to. Okay? In this case, the x value would be 0, and the y value would be -6 feet. And I'll go ahead and hit enter. So sometimes it's easier to use that relative coordinate. So let's practice with the relative coordinate again. So this next one, I want to go over by 12 feet. So this time, relative to this point, it's going to be at, again, that starts the relative command, 12 feet, 0, because nothing in the y. And I'll go ahead and hit enter. And then I can come down this direction And so it would again be at, what is this, 0, negative 12 feet. There it is. I could go back this direction, again, at negative 12 feet, 0. Incidentally, I could put 0 feet or 0 inches. 0 is assumed to be 0 inches, but obviously 0 is 0, so we don't have to worry about it too much. Okay? So then I could go down this last bit. Now I could switch back to an absolute coordinate here. So in this case, it would be 12, 0. So instead of the at sign, I would just type 12 feet, 0, and I get that point. Okay? Obviously, I have a lot of practice doing this, so it's fairly easy for me to switch back and forth between the two. Okay? When I want to finish, you can see that there is an option for close. I can just press the close option, and I'll get that line that goes all the way around. Okay? So it's important for you to understand how the coordinate system works, but I also want to show you how sometimes it's easier to draw in Rhino. Because the coordinate systems will be relevant. There's actually an exercise coming up where it's very, very difficult to do it without using a coordinate system. And it'll make sense when we get to that exercise. So I like to introduce the coordinate system, but then I'm also going to show you in practical terms how a lot of times you would draw. So in this case, I'm going to start randomly, not at point 0, 0. So it would be hard for me to do anything but a relative coordinate here. Right? I could still do my at 0, 24 feet to get that first line. Okay? But frequently, it's easier to just type a distance and then pick a direction. So the next distance here would be 12 feet. So I'm just going to type 12 apostrophe and hit enter. And you see that Rhino gives me a line that's 12 feet long, and it asks me what direction I want that line to go. Okay? It's kind of hard to get it perfectly level, so I'm going to go ahead and turn on what's called ortho, or orthographic projection here, so that it will always go at 90 degrees. So there it is, 12 feet in that direction. Now I wanted to go 6 feet in this direction. I just type 6 feet, followed by the direction. 12 feet. Oops. Sorry. We'll try that again. I hit the wrong key. So 24 feet in this direction. 12 feet in this direction. 6 feet. Notice I don't have to type negative anymore. I just type distance and direction. 12 feet in that direction. 12 feet in this direction. 12 feet in this direction. 6 feet in that direction. And then I can type C for close. And now I have the same shape. So that's a little bit faster way of going about it. But sometimes you need that coordinate. And so I want to at least introduce that as a concept because sometimes you need it. Okay? So now that I already have this shape, we're going to continue exploring with this shape. By the way, if you want to zoom on a particular object, one of the best commands you can use, and I will reinforce this over and over again, is to select the given object, type Z for zoom, followed by S for selected, the object that's selected, and it will always zoom to that particular object. It's very, very convenient in Rhino when you're zooming. You can scroll, but this just centers the object right on the page. Makes it easy. OK, so now I have the outermost boundary of the drawing that's on the back of this sheet. Okay? And so the next thing that I'm going to do is in part 2, I'm going to use the offset command. So again, we're dealing only with our curves. Okay? And I can go up to the curve menu, and I can go to offset, which is right here. And I'm going to select offset curve. Okay? I can also, remember there's multiple ways of accessing a command. I can also go ahead and type offset. Okay? So I get to the same place in either direction, or in either way. Then I look at my command line here, and it says side to offset. And then that's asking me what side of the curve I want to offset. And then it asks me some questions. Distance. OK, what should the distance be? Well, in this case, the wall thickness is 6 inches. So we'll go ahead and click on distance and type 6. By the way, you see as we go across here that there's lines that are underlined. See, the D is underlined, the C is underlined, the T is underlined. Those are the shortcuts to access. Right? So instead of distance, instead of clicking on it, I could just type D followed by enter, and it would take me to the distance. Does that make sense? So it's giving you a help for this is what I need to do. So there's distance. My corner should be sharp. I don't need a through point. The tolerance 0.01, that's fine. Notice I also have the option for both sides. So if I wanted to offset to both sides instead of one, I could do that. And in C-plane, we're not going to worry about that just yet. And again, cap, we're not going to worry about that just yet. Okay? So I'm going to go ahead and offset to the inside. And you see that if I'm on the outside, I get that little black line with the crosshair. There it is to the inside. I want it to be on the inside. And there it is. So I now have the thickness of my wall established. Okay? So now we need to start working and drawing the doors and the windows. And again, the picture on the back is a guide for what you're doing, but feel free to change it if you want. Right? I have no problem with that. So let's go ahead and put the door in at the center of the top. So in order to snap to the center, I want to turn on midpoint snap. It's already on for me. I asked you to turn it on last class. But if it's not on, we want to make sure that OSnap is on and clicked at the bottom of the page. And then in this persistent object snap dialog that shows up right down here at the bottom, we want to make sure that there's a check mark for mid. Okay, I know it's like behind my head. It's really hard to see for you guys, right? But it says mid right there. Okay, so mid is selected. And I'll go ahead and I'll zoom in on the top here. I'm just using the scroll wheel. And I'm going to go from the middle to the middle. There it is. When I'm done, I'll go ahead and press Enter. And I end up with a nice little line segment right there in the center of my wall. So I know that my door is going to be 3 feet. So if I do an offset again, so remember it's curve, offset, offset, curve, or I could just type offset. Distance this time is going to be half of 3 feet, which would be 18 inches. Right? Now, I could type in 18 inches, so 18 quotation mark. I could type 1 foot 6 inches, which is also half. Make sense? So it doesn't matter which one you do. I'll go ahead and hit Enter. Okay, so I could offset to this side, repeat the command and offset to that side. But this is a perfect example where choosing both sides would be good, because I want to go to both sides. So I'll click on both sides, and you see it's going to do it to both sides. I'll click, and there are my 2 doors. Okay, the 2 sides of my door. So the last piece here, and we're moving on to part 3, is that I need to trim so that this becomes a hole. So I'll go ahead and I'll type trim, or I'll go up to transform. Actually, it might be under edit. Yeah, it's under edit and then trim. Or you could type trim, or you could specify the trim tool, which is right here in the toolbar. So 3 different ways of accessing trim. And the first thing it's going to do is ask me for the cutting objects. So those are the ones that do the actual cutting. So my cutting objects would be this object and this object. Okay? Then I'll go ahead and press Enter, and it'll say object to trim. So the objects to trim would be right here and right here. Okay? Those are the objects that I want to get rid of. I can also, in the world of Rhino, drag a box through the objects and get rid of both objects at the same time. That works the same in AutoCAD. Okay? The only difference is the selection in AutoCAD is either blue or green as you do the selection. In Rhino, it's just a dotted line. Anyway, when I'm done, I'll go ahead and hit the Enter key. And I now have a hole that goes through where my door would be. So I'll go ahead and select this middle line. I don't need it. We'll go ahead and press Delete. And now I have a hole for my door. So notice that the line here is separate from here and from here. It would be nice if all of those became one line. So I'll go ahead and select them. And I'm going to select from my right to my left, okay, which is going to select everything contained. This is the same in AutoCAD. If you select from the left to the right, it's everything contained within your square. If you select from the right to the left, it's everything that your square touches. You guys see the difference there? So you want to get used to what direction you're selecting. Okay, so I'm going to select from right to left to select everything. And then I'm going to go to Edit, Join, or I could type Join. And these are now all one object, okay, which is what I want. If it doesn't work, right, if I did my join, let's say say I had this, and I tried to join. If I go to Edit, Join, well, it looks like it's joined. Let me see if I can make this. Let me do it this way. Go to Edit, Join. I can see right here, 5 curves joined into one closed curve and one open curve. It's because I had an extra curve there. Okay, so we need to make sure that it's nice and clean, and we don't have those problems. Okay, so let me get rid of that curve. We'll do one line right here, there, and then we'll go ahead and join those together. Edit, Join. 2 curves joined into one closed curve. That's what we're after. Okay, so let's go ahead and add a window right in here. So in this case, I want the window to be 18 inches or 1'6" from this corner. Okay, and the default of what people tend to do is they tend to get the polyline tool, start here, 18 inches, there, and then I'll draw down 6 inches like that. Oops, right there. All right, I've drawn my first line. The problem is that this is an L-shaped line, not a straight line. So we don't really want to do that because we have 2 lines on top of each other and it's going to cause problems down the road. So instead, we're going to use something called Smart Track, which should already be on. It's the center button down here. It should say Smart Track. And this is the one thing that you really need to practice getting used to because you're going to use it a lot in Rhino. And with Smart Tracking on, when I go to select a polyline, instead of clicking at this point, I'm just going to move my mouse, and you see how I get the little end and I get a white dot right on the corner? You see that white dot? Then without clicking, I'll move my mouse in one direction. Okay? Notice that I now get a blue dot and a white line. Okay? This is now setting something up relative to that corner point. So I can type 18 inches, and when I do that and hit enter, my line is going to start 18 inches from that point. So there it is. And I could type in 6 inches, but I'm actually going to turn on something called perpendicular snap so that it snaps to the other side of this wall. So there it is. And I'll go ahead and press enter. So now, if I were to select that, see, it's only that line. There is no little L-shaped piece anymore. It's just one line. So I could practice this again by setting my point right there, moving over. There it is. And the window was 2 feet, so I'll type in 2 feet. And then I'll go ahead and draw that line. Right? So the smart taking does take a little bit of work to get used to. I'll do it one more time. We'll start at this point. We'll go over by 1 foot. I'll draw that line, enter. And once again, I'll start, and again, mouse over till you get the white square, then mouse to the right here, and I'll type 2 feet, enter. I didn't do any clicking when I did that. Okay, so if you're struggling with it, let's make sure you get that sorted out for today. Okay, so I now have those 2 windows drawn. I need to add a little bit more, so let's start with a line that would be in the center of the window. Let's draw that line, and I'll just go middle to middle, or midpoint to midpoint, enter. And you know what, let's offset that so it has some thickness. So I'll go back up to curve, curve from objects, or excuse me, curve, offset, offset, curve. And we'll do a distance of, I don't know, 5/16, which would be a total of 5/8. Let's do both sides. There it is. And let's get rid of the line that's in the middle. I'll just press the delete key. And there it is. Okay, maybe I want to save myself a little time. Let me take these 2, and I'm going to mirror them to be over here. So I'm going to use transform and then mirror. There it is. And it's going to say start of mirror plane. So in AutoCAD, it says start of mirror line because you're working in 2D only. In Rhino, it's a mirror plane because it's 3-dimensional. What we're doing right now is 2-dimensional, but it's important to denote that. So the middle of this wall is the right midpoint. So we'll click here, we'll draw our plane, click there, and you see that we get the second set of those. Okay? So I now have those 2 windows drawn. I'm going to go ahead and draw the little door here as well. So we'll start, and I could do this in a variety of ways. Again, I could work with the polyline tool and I could say, okay, let's go over 1.75 inches. Let's go down by 3 feet. Let's go over by 1.75 inches. And let's C for close, and I've drawn it. Okay. I could also do a rectangle starting here, and this time I just need the coordinate, the opposite coordinate. So that would be at negative 1.75 inches, comma, negative 3 feet. So I just use relative coordinates, the at sign, followed by the coordinate, enter, and that creates it. So there's always multiple ways of drawing something. Okay? And it doesn't matter which way you do, it just matters that you figure out what works best for you. Okay? So one more thing, I want to draw the swing of the door. A lot of you will ask me to do that. Right here, we have the arc tool, but I'm not going to use that arc tool. I'm going to click and hold, and I'm going to choose this start, center, and direction at start. Okay? And I'll pick start, end, direction at start, and I get that nice arc. Okay? It's much faster than any of the other arc commands. Okay? So again, it's hidden underneath right here. It's the third option over. Start, end, direction at start. And there it is. So a couple other things that might be useful, right? Let me take this window. I'm going to mirror it this direction to create the window at the bottom. Right? I want another window that's over by 6 feet or 6 inches. So let me type 6 inches, and I'll draw that. Right? I could take this half of the window, and I could. There's two different copies that are available here. The edit copy is if you were taking it outside of Rhino. The transform copy is with a base point, so that's the one I want. I'm going to go to transform, copy, or type copy, and I'll copy from this point to that point, and hit enter when I'm done, and that creates those two windows. Okay? Let's say I wanted a window here. I could draw it, or I could take this window, and I could use my mirror plane again. So I'll go to transform, mirror, and I could do it on a 45, which I know you guys remember seeing me do in AutoCAD. Same strategy, where I can create that mirror there in that corner. Okay, so there's more. There's a sync. There's a variety of other things. I give you a list of other commands that might be worth exploring, including, let's see, extend, fillet, chamfer, mirror, rotate. Extend is the opposite of trim. So let's say that I had a line. Let me turn off Ortho for a second. I had a line there, and I have a line here, and they don't intersect. I could extend, which is under edit, extend, I think. No, it's probably under transform. I always type it, so I apologize. Let me go ahead and just type extend. Select boundary object. That would be this object. Enter when done. Select curve to extend, that one, and it extends this one to meet that one. Okay, so that's extend. A fillet gives us a radius. So if I type fillet, I can specify a radius. Let's put a radius in of 1 foot. And it says first curve followed by second curve. Now they connect with a radius. Okay, it might be something that you want to do. All right, so that would be fillet. Oh, incidentally, one of the other great tricks, and this works the same in AutoCAD, is you can do a fillet with a radius of 0 to create a sharp corner. So I can make these two meet at a corner using a radius of 0. Okay? It's just that it's a little drawing trick that's there. Let's see, fillet, chamfer. Chamfer is a squared corner or an angled corner. So chamfer would be, let's do a distance of 1 foot. And if I were to do it, it would be here to there. It creates the little angle on the corner. So that's a chamfer. We already did mirror. And the last thing that may be relevant is rotate. If I were to select an object, I could go up to transform, rotate. We'll cover what rotate 3D is next class. But for right now, it's just plain rotate. Center of rotation, there. Angle or first reference point. If I wanted this, for example, to come up until it was 90 degrees. There I can make a jump to 90 degrees, and now that would be at 90 degrees. So just rotate. Okay, so we've covered those as kind of a basic. I'm going to turn you loose to practice the drawing. Again, feel free to embellish it however you want. You can change it, you can add to it. This will be worked with again next class. So you want to make sure that you save it. We're going to bring this into being a 3D little model when we move on to next class. So when I'm done, I'm going to make sure that I go to File, Save. And I'm going to save this. One of the things that's different from last semester, for those of you that weren't in digital tools, you'll have to bear with me for a second. Remember I emphasized Dropbox? Okay? Because we're running Windows 10 now, it appears that the best strategy rather than Dropbox is to use your OneDrive account, which is through Microsoft. All of you have a school email address. If you sign up with that email address in OneDrive, I think you get 15 gigs of storage that will sync. And you can choose to have your storage location in one of your, on your flash drive as part of this. And since you will have your own computer here with your own login, you can actually go ahead and set that up. Okay, so if you want to do that, I'm happy to help you. I already have it set up here. There's a little OneDrive link. Here's my live demonstrations, 136. And here is exercise 202. So I'll save this as exercise 202. And I'll go ahead and save. Now, before, I need to be able to make sure that I post something to the course website today. Okay, so just like we did last class, let me make this fit. I'm going to do Zoom selected. And on the handout, I ask you to do a print. I'd rather have you just do a screen capture. It's easier. So I'm going to click on the little triangle next to where it says top there. And I'm going to come down, and I'm going to go to Capture, to File. And then I'll go ahead and save it again into today's folder. And it'll be exercise 202 JPEG. I'll go ahead and save. And there you go. Now I will have, if I go to my file browser here, right, there's a JPEG of what I did. Okay, that's the file that I'm going to post to the course website today to prove that I was here and I worked on it. Okay? So again, make sure you save the 3DM file right here and the JPEG. The JPEG is the only one that you post. That's nice. The JPEG is the only one that you post, but the 3DM file we will use next class when we start to build this in 3 dimensions. Okay? I recognize also that some of you will breeze through this and it'll be very fast. If you do, great, congratulations, you're well on your way. If it takes you the whole time because you haven't worked in this before, take your time and make sure you really understand what's going on, right? We do a lot of skill building in the very beginning. So we will all get to the point where you're doing much more sophisticated things. But at the beginning, we have to kind of start with the basics. It's the nature of a class like this. All right? Anybody have any questions? All right.